The Advanced Structures and Composites Center at the University of Maine is one of our premier organized research units. The goal of the Advanced Structures and Composites Center is really to look at commingling different materials that we would call composites, materials made up of two dissimilar materials, to get the best benefits for the application. And in general, the Advanced Structures and Composites Center focuses on large structural application. The Department of Defense actually asked us to look at using inflatable structures, inflatable arches, in ways to build rapidly deployable buildings or bridges. The evolution of that is a project we call Bridge in a Backpack, which uses multiple arches, composite arches that are inflated soft and then are rigidified by resin infusion, then filled with concrete to have a stay-in-place form in which to build a bridge over a small stream, river, or roadway. Within the center we have a small pool that is used, it can be either fresh or salt water immersion tank, that can be used to start testing scale models that are going to be either floated or sunk or somehow deployed in the water. We use that extensively for our scale models of offshore wind turbines. We're using it for some work doing with some aquaculture companies now, looking at different types of floating technology to support mussel rafts. Any type of structure that's going to be either floated or submerged, total immersion, we can use that tank for. I think the Advanced Structures and Composites Center, the efforts that we're working on in renewable energy, especially in the offshore wind area, are one of the biggest projects that address climate change. We know that the winds in the Gulf of Maine is one of the strongest renewable resources, the strongest energy resources that Maine has access to, and the Northeast has access to, and perhaps most of the United States. With that amount of energy out there, renewable energy, there has to be ways that we can cost-effectively take advantage of that wind resource, converting it to the energy sources that we need to live every day.
So basically students use these various materials and they invent their own floating wind turbine. And basically what they do is they put them together, they see what works, what doesn't, and then they can bring it here to our simulated wind wave tank, where we both have wave makers from a saltwater aquarium. We have this freshwater tank filled with water, much like the Gulf of Maine is filled with water. And we also have a wind generating fan, much like a fan you would buy at Family Dollar, or you may already have at home. Where basically you can simulate both waves and wind here in this Gulf of Maine simulation. So students at the expo will get to perform this activity, and the goal is to make the most efficient floating wind turbine possible, make it the most stable, make it the most attractive, and have it work the best.
I think the Advanced Structures and Composites Center, I think the University of Maine in general, believes that participation in expos, by showing new technologies, developing new technologies, but also working very collaboratively with other companies that are developing, or other institutions that are developing new technologies. So good opportunities for us to work with and support other programs that are developing new technologies and that might apply. And so being at the expo, not just to show what we're doing, but to show that we're available to help any of these companies, whether in Maine, New England, that's what we do all day.